Hi, my name is Patrick and I work at VOI, that is a Brazilian railroad, and today I will present to you the work evaluation of used concrete, steel and composite cross ties interspersed with wooden cross ties in our railroad VOI. First, I want to present the VOI. VOI, as I said, is a Brazilian railroad with more than 5,000 miles, and our key segments are agriculture products, steel industrial products, and manufacturing goods. It's a general freight railroad. And here we have a special corridor in VOI, Minas-Bahia corridor. Is the biggest corridor of VOI with 1,100 miles, 3 million of wooden cross ties, and in January, low density, low annual tonnage, low operation speed. Here our wooden cross ties has only 5 years of useful life. In this corridor is a jointed track with a lot of rail joints. We have a backlog of sleepers and rail anchors, and also full of ballast. This is the main parameters for this work. So it's a typical corridor in terms of maintenance. It's not good. In general, what is the motivations for the campers for interspersed wood with concrete cross ties or other materials cross ties? It's economical issues, as we can see here with Minas-Bahia. And in general we have also geometric problems, especially widening gauge. So we need to solve the geometric problems quickly, and interspersed is maybe a good solution. However, there are many studies that not recommend this solution due to the incompatibility of stiffness between traditional concrete and wood. In general, it is necessary to use special concretes to equalize the difference in stiffness. So, for traditional concrete, it's not good interspersed in terms of literature. But we tested for studying our conditional operation. So the objective of this study was, can the interspersed of wooden cross ties with alternative cross ties be a viable technical solution for the Minas-Bahia corridor? So for our case, is it possible interspersed? Here, as I said, we have only 5 years of use of life for wood, and for concrete we consider here 40 years, 24 years for steel, and 15 years for composite. We interspersed with all of them for study. Okay? So, the first curve, the concrete, here we can see we installed the concrete with one concrete for 2 wood. We developed a special structural project for the concrete with these parameters. In terms, is a small concrete cross ties. The normal situation, the concrete is bigger than our studied here Minas-Bahia corridor. the same we did to steel 142. We used a special profile, steel profile 2, smallest than the normal. Is a PR51 profile, okay. Our gauge here in Brazil, in our rural, is a metric gauge, 1 meter of gauge. Okay, and the same to composite crossties 142. Here in Brazil, our composite crossties, the matrix polymer is high density polyethylene, and the dimensions of the composite crossties is the same of wood crossties. Okay, height, length. Okay, the same dimensions. And the fastening systems for concrete and steel, we use it here Brazilian clip. The name is Denic, as we can see, with high density polyethylene rail pads, because this fastening system is cheaper in Brazil than the others, like Fast Clip, a Clip. So we decided to use the cheaper for Minas-Bahia corridor. And for composite, we use the same fastening system that the wood crosstie use. It's a triphone with tie plate. Okay. As I said, we have here in Minas-Bahia corridor a full ballast. We know that's not good, not recommended, and we wanted it to test in this situation, like we have here, full ballast in all cases, for concrete, for steel, and for composite. Okay, 3 curves. Here, a special conditional. In the rail joint regions, we remitted the wood crossties, because here we know has a high elevate vertical loads, and we decided to remit the wood in these regions for concrete and for steel curves. Okay, but for composite, we installed the composite ties in the rail joints regions. Okay, it's an advantage of composite, because in theory has the mechanical behavior similar to wood crossties. Here you can see our curves. 142, like you can see, we installed in September 2010, the city Montes Claros, Minas Gerais in Brazil, and this is our degree of curve, sharpish curve, and the tamping was mechanical Z for concrete and steel, and manual for composite. Why? Because we know that tamping is so important for all crossties, especially for concrete and especially for steel. Here we have a backlog in tamping in wooden crossties maintenance, and so in theory composite crossties has the same behavior, mechanical behavior as the wood, so we decided to install without mechanized tamping, just manual. Okay, so we evaluated these parameters: the gauge, delta gauge, and twist, crossties failure, tie plate cut, and the torque of tire phones for composite. We monitored it for 8 months, 1.8 mg here for us, and let's see the results. For the gauge, we measure it with a rail gauge ruler in 12 points for 1, 2, 3, 4, 5, 6 inspections along these 2 years. And what we can see, the gauge in average remained, so it's very good for us, and decrease a little here in the last inspection. So that's a very good result. The gauge need to be remained for good cross ties. The main feature of cross ties is remained the gauge. So the results for concrete proof was very good. Okay. And for steel, the behavior was similar. The gauge remained for all the test period. Okay, so very good results for steel. That our main objective for use concrete steel, because the gauge are fixed. So that's very important for the railroad. For the composite curve, here we can see the same result. Actually, the gauge decreased. It's a false result because here we have one limitation, because the rail has a mechanical deformation, so the gauge we can see decrease, but because of the mechanical deformation of the rail. So in general, we can conclude that the gauge was the same during the older periods. So very good result for composite. All composite, all alternative cross ties has the good results. Excellent for us. For twist, we can see here before the installation the concrete curve had defects, and after the installation the defects are continued. Even the tamping process. We conclude that it's chronic problems of this curve, and the concrete doesn't increase the problems. Actually, we can see the last inspection the number of points of defects is lesser than the others, so the concrete doesn't increase the defects here. We can see, and the value is a short defect, not so bad for us, so far from our limit, okay, especially in the last inspection. The similar behavior for steel, here we can see for the last inspection smaller points, and the same conclusion for steel, okay, and for composite also too. Here we have a chronic problems with twist, and the alternative cross ties doesn't increase or decrease these problems. Okay, very good. So in the visual inspection, you can see here the concrete doesn't crack. We have here 0% of failure in concrete. Very good results. The curve was very good, so a good results for concrete here. Our last inspection was 1.8 mg/tier. The same for steel, 0% of failure. Excellent results as we wanted. But we have here some points of attention, because our wood now has a high elevated deterioration of decay. So we know the vertical loads increase here for the concrete and steel cross ties. So we will need to monitor this situation. We are thinking to do instrumentation, field instrumentation for measure this force and the bending moment in this cross ties. Here, especially for concrete, we had a failure in the rail pad, with the rail pad. As I said, we have a backlog with rail wrenches, so the rail move high. So with low tensile hastening with the high density polyethylene, the rail pad broke. So we need to develop a better project with other material, maybe for study what's the best rail pad for this situation. As I said, we chose the cheaper, the more cheaper material. So maybe now we have to choose other material to solve this problem. For composed, perfect results without cracking, 0% of failure. For concrete, for the cross ties, and for the fastening system. But we monitored the torque, and we can see here we monitored for 11 points the high rail and low rail, and in average, as we can see here, the torque decreased. So important, we need to solve this problem. And in the field we can see the problem, the uplift of the tire cones, so we don't have torque here in this tire cone. So we need retired this tire cone. Maybe the cycle of retired be a 1.4 MDT. Okay, and that's it, our conclusions for yet. The performance of all types of sleepers was considered satisfactory until the last inspections. The failure rate was 0%, even in a full ballast, and 10% with high deteriorated wooden cross ties. So that's a very good result for yet. We will need to continue monitoring the curves and the cross ties to study the solution for Minas-Bahia corridor. So we will do field instrumentations for check the increase of vertical load and bending moment at these cross ties, do the intercalation with high deteriorated wooden cross tie, and also develop a new project for high rail pads with other material, other projects. So that's it. Thank you very much. Here our reference. Thank you very much.